All right, so this is the last section. This is part 4. And this is called angles of elevation depression. There are a lot of applications for using trigonometry. And so we're going to get into some of the word problems. Some of the vocabulary seems a little confusing, but the concept is very simple. To elevate something is to raise it up. And when we talk about depression, we're not talking about emotionally. To depress something is to lower, to push down. Okay, so elevation is to raise, depression is to lower or press down. I'm going to draw 2 examples, and I apologize ahead of time for my drawings here. But let's say you're walking down the street. Okay, that's you. Normally, we are looking straight out. Okay, when you're looking, this is horizontal. We call this a line of sight. Our line of sight. The line of sight is horizontal. That's why we call, by the way, when you go to the ocean and you are looking out as the sun goes down, we call it the horizon. The horizon is where the sun would meet, where the sky meets the waves, and the sun is sinking below the horizon. Horizontal is straight across. Now, let's say line of sight, but then you notice up in the air is an airplane. So your eyes, you cast your eyes upward, okay? I'm not saying that you lean your neck back, but your eye level goes up. What that does is that creates an angle here with your line of sight, and because your eye level was raised, we call this an angle of elevation. Angle of elevation. That's all that is. Now, in the same way, let's say you're walking down the street, and this time, here's line of sight again. This time you see, hey, there's a little dog. Okay, again, I apologize, that's 4 legs. There you go, there's a dog. This time you cast your eyes downward from your line of sight, from the horizontal. Now what we're talking about is an angle of depression. Okay, so elevation, your eye level goes up. Depression, it goes down. But they both start from the horizontal. That's the key. So let's do 2 more problems here. Number 9. A surveyor is standing 115 feet from the base. That's the bottom of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. How tall is the Washington Monument? Well, one thing we always want to do with these problems is to get a picture. If they don't give us one, let's draw one. So you've got a person standing on the ground because they're standing from the base. If you've ever seen the Washington Monument, it's an obelisk, which is this kind of shape right here. Now, what the surveyor is doing, they're standing 115 feet from the base. Now, distance is always going to be a perpendicular. Okay, so I'm assuming that the Washington Monument is standing up straight. Okay, so that makes 90 with the ground. 115 feet from the bottom. The angle of elevation, so they're looking to the top of this. Their eye level goes up from the horizontal. The angle of elevation is 78.3 degrees. How tall is the Washington Monument? So here's X. Now we have a right triangle. Pythagorean theorem, you can always try that first, but we're not looking for the hypotenuse. We're not looking for that distance. We're looking for this height, and they give us an angle measure, so that's a big clue that this is probably trigonometry, SOHCAHTOA. So because we think it's SOHCAHTOA, we're going to circle the angle. We're going to label the sides. The X is the opposite. The hypotenuse is the blank. We're going to cross that out. And then the 115 is the adjacent. So, ka, toa. Opposite and adjacent is a tangent problem. That is toa. So we'll say the tangent, tan 78.3 degrees, equals opposite, which is x, over adjacent is 115. Now, because we're looking for a length, we're missing a length, we're going to cross multiply. So I'm going to put this over 1. Here's my proportion. 1 times x is x. And this is 115, not times 78.3, but times the tangent of 78.3 degrees. And now it's a calculator problem. So 115 times tangent 78.3 equals 555.3 feet. So x is equal to 555.3 feet. That's actually true. That is the height of the Washington Monument. It is important that we put feet. Meters is not the same. If we're traveling, if we were on the ocean, for example, in a boat, there's a huge difference between feet and measures. Those are not the same types of measurement. So we do want to put the units of measurement. That is important. All right, the last one here, number 10. From the top of a vertical cliff 40 meters high, so now it's meters, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? All right, this one might be a little more confusing, so let's go piece by piece. From the top of a vertical cliff 40 meters high. So let's start with that. Vertical means up and down, so I'm going to draw that. Here's my cliff. We know it's 40 meters high. So from the top, that means we're up here. The angle of depression of an object that is level with the base of the cliff. So let's say this is water down here, and let's say we see a boat. All right, there's a boat. Angle of depression, again, we're starting from here. So think line of sight, that's straight out. Angle of depression, we cast our eyes downward and we see this boat. That is this angle. Angles of elevation, depression start from the horizontal, and that is 34 degrees. Now the question, how far is the object from the base of the cliff? So the object, let's say the boat, we want this distance here, that's x. Because the cliff is vertical, that's a right angle. So notice that we have a right triangle. Now, one thing you might say, though, is, whoa, Mr. Cavell, we don't know either of these two angles here. How can we set up a trig ratio if we're going to be missing an angle measure and missing a length at the same time? Well, the key is this is a line of sight. This is horizontal. And because we're assuming that this is horizontal to make a right triangle, what happens is we actually have parallel lines. And because the lines are parallel, the alternate interior angles must be congruent. So we actually do know this is 34 degrees. That is in the triangle. Now we can circle the angle. The opposite side is 40. The adjacent is x. And now we can make our ratio. Again, opposite adjacent, that is a tangent problem. So the tangent, 34 degrees equals opposite over adjacent. Because we're missing the length, we're going to cross multiply. Now what happens, the x is multiplying tan 34 degrees equals 1 times 40 is 40. We've got one more move here because we're we're solving for x. We have to undo the multiplication. To do that, we divide by tan 34 degrees. This reduces to 1, x equals, and this is a calculator problem, 40 divided by the tangent of 34 equals 59.3. So x is 59.3 meters. And that is the end of part 4.